Cool. All right. Hello, everyone, and welcome to the Bugcrowd stream. My name's Casey Ellis. I'm the founder, CTO, and chairman of Bugcrowd. And I've got Coen with me here today. He's the head of infrastructure, been with Bugcrowd for forever and a day, it feels like, in all the right ways. We're going to chat about the Parler hack today. So g'day, mate.
Hey,
And
good to join you.
Yeah, for those listening on, we're not all Australian working at Bugcrowd. It's just the good ones. So, we'll run with it like that. So yeah, look, we wanted to talk about this kind of series of things that happened with Parler. We actually presented this in town hall, and I wanted to get Coen on as a infrastructure guy for Bugcrowd, but also as an infrastructure veteran that's seen a lot of stuff in his own startups as well as helping others, because I think there's some lessons that can be learnt from it, some things that can be talked about in terms of what actually happened to help understand that. And we're going to have a bit of a banter around it. So, yeah, did you want to start anywhere, Coen, or shall I run through the hack?
You run through the hack, and then I can jump in and add commentary.
No worries. All right, cool. So yeah, Parler, I think on this stream, separating kind of what went into all of the stuff with Parler from a political standpoint and all of that, keeping that almost to the side and just talking about the tech and what happened from that standpoint, just to kind of keep it simple, and to make the learnings as useful as possible to as many people as we can. But in essence, what we saw happen was really a combination of, basically hypergrowth architecture with security decisions and even scalability and kind of resilience decisions kind of sacrificed in the pursuit of growth, which is a thing that happens a lot. I think it's very easy to point fingers at it, but in reality, it's something that happens all the time.
Right.
That kind of blending together with a bunch of folk wanting to get information out of Parler, and I think it being quite visible that they had some failure modes that were exploitable. Their apps were taken out of the Apple Store, and they were sort of not gradually, over the course of a couple of days, basically deplatformed from different infrastructure providers. And as that happened, there was a whole bunch of stuff that kind of broke in really unexpected ways that the internet piled on and kind of took advantage of.
Yeah, it's a whole bunch of little things, I think, and I'm certainly appreciative of when you have they were obviously unprepared for everything that went down, and they had a lot of growth, and it hit them pretty hard. All these little things that they did what went wrong. It's like, okay, you messed that up. That's kind of that's kind of a mistake. But there was kind of quite a few of those, and we can kind of go through them and talk about the mistakes that happened. But in startups, like, it's hard. I think what's the crux of what happened here is that they MVP'd their product, and they built on top. They continued building it, and they just got hit with a lot of growth. Started throwing money at the problem, and there's some architectural decisions we can talk about there, and just never really got to fixing things up before shit hit the fan.
Yeah, I think that's a good way to put it. I gave a talk for TechCrunch Disrupt earlier in the year, last year, a million years ago in 2020, talking about Bugcrowd's experience of that, because the reality for startups in particular is that, like, the bad guys don't care. And really your biggest risk early on is your next payroll for your team, not so much getting hacked. I think that's starting to change in how true it is. But the balance of how to prioritize cybersecurity in an early stage company is very different to when you're scaled, because obviously when you're larger, you attract the attention of more people and your threat model changes. But this talk that I gave was really around how Bugcrowd, because of the essence of what we do, there was a whole bunch of stuff that we had to think about pretty much from day one that you usually don't, and how we approach that. Because what I realized is that's just unusual. That's not normal at all. I think there's some learnings from there. But yeah, I mean, talking about going through what happened, that was kind of the architectural root causes and the backstory. really what that netted out to was a bunch of pretty serious privacy impacts on their users. So there was an IDOR, one of the particular ones that was quite impactful was the fact that they weren't, I think they had posts or messages that were public stored with sequential integers. And when a post was deleted, it wasn't actually deleted. You could still basically access it by incrementing that integer. It wasn't, it didn't have access control changed in front of it or anything else like that. It was just kind of not linked to anymore. And a bunch of people figured that out and pretty much scraped all of the content on the site, including the content that the authors intended to have removed at that point in time, which is obviously kind of an issue.
Yep. Well, there's a couple comments I'd like to make about those.
Yeah, sure.
I mean, obviously, integer IDs. Let's talk about that. And there's two things about that. I guess it's one there. It makes IDORs very easy, right? If there's an IDOR that exists, it's easily exploitable with a auto increment ID. So everyone just use UIDs for that purpose. It makes things more difficult.
And just to pause you there for a sec, because I realized we just committed an acronym foul. What is an IDOR?
Indirect object reference.
Right. And what's the impact of an IDOR, I guess, or how does it work?
Well, it's access bypass usually, in terms of like exploitability and how ramification. Like if you have, let's say for example, let's say we have an API and there's two users on the API. There's Casey and there's Coen, and we have our own documents on this. It's accessible through this API, and I should only have access to my stuff. Casey should only have access to his stuff. But Casey goes, oh, okay, well, I know the document ID of Coen's stuff. If I make a request there, I can pull that down, and now I've got Coen's stuff. And so, what happened there on the server side is there wasn't a proper access control. There wasn't a check to make sure that the requesting user is the same as that owns the content that's being returned. So those kind of things, should be implemented at a low level in the application. So you're not implementing checks at every endpoint. You want to make sure that you have a sort of a central system where access controls is kind of determined, right? And so you should be able to implement one place, and then these kind of things are more difficult.
Yeah.
But
more difficult. Yeah.
We also committed another. I also said UID, which is probably not very. So UID is a universal unique ID. And it is another form of ID. Like an integer ID is just a number, and a sequential integer ID, as it sounds, is one after another. So if Casey's document is 4 and mine might be 5, Casey can guess the ID of my document very easy. It's probably going to be 5. But a UID is 32 character random. It should be random, so long as you got a correct. You're calculating correctly, random ID. So what that means is that it's very hard for Casey to guess that, because if there's only 2 documents on the system and Casey has one 32 character ID and I have another, it's like how can you guess that? Like it's very
it's an interesting one, because I think security professionals, including myself, I've been guilty of this at times, saying, "Oh, security by obscurity is not a strategy at all," which is not quite true. I think security by obscurity, where you're basically just relying on no one finding a thing for it to be secure, there's a whole lot of areas in security where you shouldn't do that. But it is a viable strategy. You look at password link resets and even what we're talking about right now with public content. It is a part of a valid architectural strategy for protection of user information, right?
Yeah. I mean, single live token, like this UID context, like you wouldn't want to just rely on the fact that the UIDs are hard to guess. That would be bad, right? Because if there's leaks, then it can be, but it can limit the damage of something like this that happens, right? So you can't you wouldn't be able to pull down 70 gigs worth of data because you guessed UIDs.
Yeah, no, totally. So really that idea of, your recommendation there is around, calling out the UUID piece. I think as well, not relying on linking as a form of access control, and making sure that, especially as you grow as an organization or as a app within an organization, that you're doing more around your actual access control mechanism. So if you need to remove access to content, you can do that in a real way, not just by pretending it's not there.
Right. Yep.
Yeah, that's cool.
Another thing is, with these IDORs, APIs, I love testing APIs in terms of like automated testing request specs, because they're really easy, right? Like, APIs should be idempotent, and it's inputs and outputs, right? So access controls and making sure that IDORs don't exist should be part of your request, your test, right? You should have make sure that your endpoints aren't, that this vulnerability doesn't exist. So often people, when they're writing tests, they just write for making the happy path and make sure that the thing does the thing it's supposed to do. Yeah. But you also need to test to make sure that it doesn't do the thing you don't want it to do.
Yeah, totally. And I think that takes, yeah, well, that sounds familiar, right? That takes me to one of the other pieces that came out that kind of jumped out at me. Like we, in a Bugcrowd context, there's a couple of vulnerabilities that everyone always seems to try to find and submit, and we see it a lot of the time. They don't on their own constitute a huge risk, but in combination with other things, they can become a problem. And EXIF data and EXIF data stripping on uploads is one of those, right? In this particular case, the fact that EXIF data wasn't stripped from photos and media that was uploaded to a social media platform, and then obviously there was a threat model that kind of came up where people would want to pull that EXIF data out and work out how to use it. That constitutes a pretty major security error, really. And one, I guess what I'm interested to hear just briefly from you on that one is, how do you get to a point where you've got like millions of users and you've forgotten to strip EXIF data from your social media platform?
I actually think it's probably pretty easy, right? Yeah. When you're struggling to scale, the easiest way to solve a file uploads is just to do something like just have the client push directly to S3 or some cloud storage, right? So then you don't have to process it. It takes a lot of work to kind of take large files like that, process them, modify them, put them on somewhere else. So by default, the thing you're going to do is just have the client upload directly to the cloud storage, which means that you've now got to do some other work, and they probably just never got around to it. Maybe they didn't know they should be doing this. I don't know, but
or maybe, I mean, to your point, maybe it was expensive, because that like going back to what we were saying at the start, like as a startup, it's always a trade-off, right? Like security is a thing that you have to work pretty hard to have it turn into like growth or top line for the business. It's usually just insurance against something bad going down. And while you're small, the likelihood of that is lower. So, EXIF data stripping, that's computationally expensive. Our cloud bill will go up if we do that. So let's just wait a little bit. And in the meantime, you hit, some sort of viral hypergrowth, and all of a sudden you're like, whoops.
Yeah. And then all your resources are spent scaling and product development kind of stops probably.
Yeah, definitely. Can you speak really quickly, because I'll come back to that before we sign off here, because I do think, to me, one of the fundamental root causes of all of the ruckus was just really a lack of threat modeling. The idea of like, they clearly weren't thinking about what could go wrong as much as they were thinking about growth. But we'll come back to that. When it comes to architectural decisions, you tapped on this just before, like horizontal versus vertical scale and all that sort of stuff. Do you want to speak to that real quick?
Yeah. Well, the sequential integer ID speaks to that again. Yeah. That makes things really hard to scale, right? If you have sequential IDs, that means you have to have a lock to allocate an ID. So you have to have a central point that's making that decision. And so if you're talking about you're trying to build a social network, that's probably not a good idea to make, like good thing to make if you want to have like a huge platform and have that lots of growth. So this kind of ran into I saw a bit of info about how they were talking to an infrastructure provider looking for servers, and one of the requirements were that I think they needed 100 servers for a Postgres cluster. I think that's what it was, 100. But then, like, that's a lot to have part of a single cluster. And so I think what's happened is they went with integer IDs, and because they had required the single point of decision making, all they could do is just grow this cluster to a scale that by the time you're at 100 nodes, they all need to talk to the master, and the master needs to talk to the replicas. Like, you adding another like nth 101 node, you're not going to get
really moving the needle
value for money. It's going to be diminishing returns significantly. So they would have just been adding. Yeah. And they really needed to be able to have the ability to shard. So if they use UIDs, they would have been able to allocate IDs without a central authority to determine that. And then they could have, chunks of information on separate databases and not have to have this central point of
so again, it sort of comes back to growing fast, which any startup wants to do, but then having that come at the expense of like stopping for a moment and making sure that the security and architectural decisions are sound. I think we want to we're sort of butting up on time here, so one thing I'll say just to kind of close it out is that this one does end with a pitch. I don't think every time we do this this will happen, because we want to just talk about security stuff and help people understand what's going on and try to help them take those learnings and to be able to actually implement them in a practical way. And this has been a great conversation. Coen, appreciate you kind of sharing some of your insight into how not to do a Parler. But there is also this element of really the role that the breaker mindset plays in getting highlighting the areas where this might be necessary earlier on in the life of an organization, and to have that be a continuous feedback loop between people that are thinking about what's going to go wrong, because that's how they're wired, and folks that aren't necessarily as wired up to do that sort of thing in the first place, because they're building and they're trying to grow. So that really is the essence, I think, of Bugcrowd as a company, is connecting those two mindsets together to basically be in a position where you can have information that you can action at the right time in the organization to incrementally deal with this stuff before you have to go and do a big forklift like they're having to do at the moment. So get in touch if that's something that you're not already doing, or if you're interested in doing as a viewer of this one, because there's a lot of different ways that we can actually connect the crowd to your environment to give you that feedback on an ongoing basis and at points in time as well. We'll call time there. So thank you so much, Coen. Really appreciate it, mate.
Thank you. Yeah, it was great talking with you.
Cheers, you too.